If a snowball in the shape of a sphere is melting its surface area at the rate of 12 pi inches squared per second, at the instant the radius of the snowball is 3 inches, find the rate at which the A, radius changes, and B, volume changes. We are given here the rate at which the surface area, S prime, or ds dt, will be changing, and it's melting, and therefore it should be decreasing. And so this will equal to a negative 12 pi inches squared per second. We are looking at the instant that the snowball will have a radius of 3 inches. For part A, we want to find the rate at which the radius changes. We have the rate at which the surface area changes, so we will have to relate the surface area of the sphere to the radius of the sphere. The surface area of a sphere is 4 pi times the radius squared. There's the related variables equation. We can find the related rates equation by taking the time derivative of both sides, indicated by a prime on both sides. Every variable is implicit with time. Every variable will have a prime in the derivative. On the left side, we have the derivative of 1s. The derivative will be 1, but then times s prime for the chain rule. On the right, we have a 4 pi r squared. It'll be a power rule. Bring down the power 2, multiply it with the 4 pi. That will give us 8 pi. Subtract 1 from the power and then multiply by the derivative of the inside, and that will give us an r prime. Every variable is implicit with time. We'll end up with a prime in the derivative. The result is a related rates equation. We have all the numbers we need here, so we can plug in now, and negative 12 pi equals to 8 pi times 3 times r prime. So we have negative 12 pi equals 8 times 3 is a 24 pi r prime. And we can divide a pi from both sides and cancel those out before we continue. And now we can divide both sides by 24. So we have a negative 12 divided by 24. Well, 24 is divisible by 12. If you divide the numerator by 12, you end up with a negative 1. The denominator, you end up with a 2. So we end up with negative 1/2. Therefore, r prime, or dr dt, is equal to negative 1/2 units, radius, measured in inches, over time, measured in seconds. For part B, we want to find the rate at which the volume changes. We have the rate at which the surface area changes, and we have the rate at which the radius changes. We can relate the volume to either one of those two. It'll be simpler to relate it to the radius instead of the surface area, because we have a simple formula for the volume in terms of the radius. The volume of a sphere is 4/3 pi r cubed. There's the related variables. From the related variables, we can then take the time derivative of both sides to produce the related rates. Indicated by a prime on both sides. Left side, the derivative of v is 1 and then v prime. On the right side, we have a power rule. The 4/3 and the pi are constant. Bring the power down, subtract 1 from it, and then multiply by the derivative of the inside. Remember, every variable is implicit with time, and we'll have a prime in the derivative. The 4/3 and the 3 can multiply, and the 3's will cancel. So v prime is equal to 4 pi r squared r prime. We can now plug our numbers in. V prime will be 4 pi times 3 squared times r prime, which is found to be a negative 1/2. So v prime will equal 4 times pi times 3 squared, which is a 9, times a negative 1/2. So 4 times 9 is a 36 times that pi. All of that's in the numerator. We will be multiplying this with a negative 1/2. So we multiply the numerators, which will give us a negative 36 pi. And we multiply the denominators, which there's only one denominator, so that ends up over 2. 36 is divisible by 2, so this comes out to negative 18 pi. Therefore, v prime, or dv dt, equals negative 18 pi. Its units will be volume. Volume is in length cubed units. Our length in this problem is inches, so inches cubed. And then over time units, which is seconds. Negative 18 pi inches cubed per second.